Hello. So, in the last lecture, we talked about combination of springs. Now, let's talk about a new topic, that is motion of a block under constant force. So, suppose there is a spring block system having mass F. So, if a constant force F naught acts on it in a direction, say positive x, then this block will be displaced and the spring will stretch. So restoring force acting on the spring is, say, F equal to minus kx. So what would be the net force acting on this block? F equal to minus kx plus F naught. Remember that minus kx and F naught are acting in opposite direction. The constant force is acting in positive x direction, whereas this restoring force is acting in negative x direction. It would be just opposite. So net force is F equal to minus kx plus F naught. Now, what about at mean position? We know that at mean position net force is 0. So this implies kx equal to F naught, and if x equal to x naught is the mean position, then x naught comes out to be F naught by k. So what is the mean position of an object under a constant force? It is F naught by k. Now here one question I would like to ask with you all. If this constant force is not present over there, that is, for a simple spring block system, where is the mean position? If you know, you can answer in the comment. However, here we have come to know that if constant force acts, then the mean position is F naught by k. And question for you all is, where would the mean position lie if no constant force acts on the body? Now, we have seen that case, and for that equation of block was F equal to minus kx, and we have solved that and got x double dot plus omega square x equal to 0. Now here what will happen? How will the equation change? So here, since F equal to minus kx plus kx naught, that comes out to be, we can write F equal to ma, and a can be written as x double dot. Therefore we get mx double dot plus kx minus x naught equal to 0, and here x minus x naught we have replaced with capital X. Therefore we get mx double dot plus omega square x equal to 0. So this is once again a second order differential equation, and we get its solution to be also x equal to a sine of omega t plus delta, where a is the amplitude and delta is the resultant phase. What is the frequency? It is equal to under root k by n. Yes. Now next is pendulum. So basically we will study about two pendulum, simple pendulum and compound pendulum. So first let's talk about simple pendulum. So as you can see in the figure, there is a simple pendulum and a bob of mass m is connected with it, and it is at its extreme position at a displacement of theta from mean position. There is a simple pendulum in which bob of mass m is at its extreme position at an angular displacement of theta from its mean position. So there would be a tension in the string, and that tension is balanced by, how will we balance that? We will resolve mg into two components. So we got mg cos theta balancing tension, and mg sin theta is responsible for the SHM motion, right? So here, which is responsible for SHM? Mg sin theta. So we are writing it F equal to minus mg sin theta. Remember, this is very important because this is the restoring force here basically. So F equal to minus kx, we write it F equal to minus kx. That's why we are writing it out F equal to minus mg sin theta. Yes, this is this negative sign is showing that this is the restoring force which is acting on the body. Yes. Now you can see in the figure that sine theta equal to, if you can see clearly, there is a right angle triangle being formed. So sine theta equal to, if this distance is x, then we get x by L. So if sine theta equal to x by L, then can you replace that in this second equation, f equal to minus mg sine theta? What will you get? F equal to minus mg into x by L. Now comparing this with restoring force F equal to minus kx, we get k equal to mg by L. K equal to mg by L. So spring constant k equal to mg by L. Now since we know that omega equal to under root k by m, so on solving, on replacing the value of k equal to mg by L, we get omega equal to g by L, and omega is also equal to 2 pi by t, as you must be knowing. So time period of SHM, we are getting it 2 pi into under root L by g, the very familiar equation which you must have heard in your junior classes also. Now what about the spring potential energy? Half kx square, and k equal to mg by L, you have to always remember. Okay, spring potential energy is half kx square. And what is pendulum potential energy? Half mg by L into x square. Spring potential energy is half kx square, and pendulum potential energy is half mg by L x square. So this was all about simple pendulum. Now let's talk about compound pendulum. As you can see, there is some dark picture of this compound pendulum. So suppose there is a compound pendulum where O is the point of suspension and C is the point where the center of mass of the body lies, and OC is equal to length L, right? So if this compound pendulum, suppose it is released to perform oscillation and it moves with angular velocity omega, then here force won't act, here torque will act. If you can see, one point is pivoted, so whenever a point is pivoted, then there is a chance of torque acting on the body, right? So here one point is pivoted, and you can see that the body, if entire mass is m, then mg cos theta is once again balanced by tension, and mg sin theta is responsible for SHM. So this force is acting, and there is a perpendicular distance of L. So torque will act. We know that force into perpendicular distance is torque. So F equal tau equal to minus FL. Once again, this is the restoring torque. That's why minus sign. So tau equal to minus FL and F equal to mg. So minus mg sin theta into L. Now can you write tau equal to I alpha, where alpha is the angular acceleration and I is the moment of inertia? So I alpha plus mg L sin theta equal to 0, and next we can write I theta double dot plus mg L theta equal to 0. From here we can write theta double dot plus mg L by I theta equal to 0. Now is this harmonic? We have talked about SHM or harmonic motion. So any equation of the form psi double dot plus omega square psi equal to 0 is SHM. So here this is harmonic only if sin theta is replaced by theta. So this is harmonic only when sin theta is replaced by theta, and when it is replaced, when theta is small, then only we can replace sin theta by theta and it is harmonic. Otherwise this equation is not representing an harmonic equation, and this motion of compound pendulum won't be harmonic if theta is large. So for small theta only, motion of a compound pendulum will be harmonic, and we can get theta double dot plus mgl by I theta equal to 0, and this we can write mgl by I to be equal to omega square. So what is the value of omega? Under root of mgl by I, and once again we can get the equation solution of this equation to be theta equal to theta naught plus sine omega t plus delta, right? So this was all about compound pendulum. Now next is effective gravity. What is effective gravity? So effective gravity is basically the net gravity. For example, when only gravity acts on the pendulum. Suppose there is a pendulum and only gravity we are considering, then time period is given by 2 pi into under root L by G. But suppose other force also acts on it. So due to other force, the body will be accelerated. So net gravity or net acceleration would change. So let's talk about it. Suppose other force also acts, then time period would be given by 2 pi into under root L by G dash, where G dash is the effective gravity, and that is equal to G plus sum of all the forces divided by mass of the system. So here one very important concept, pseudo force, will also come into play. Suppose there is a pendulum which is hung in a lift which is going upward. There is a condition is that there is a pendulum which is just swinging in a lift which is going upward with acceleration a. Now, what would be the force acting on this pendulum? There is a concept of pseudo force being used. So F equal to mg and T equal to mg if T is the tension of the string and T equal to mg. But that answer is wrong. Net this body is going upward, this lift is going upward with acceleration a. So net force would be given by, you have to apply a force ma on this body in the opposite direction in which this lift is going to get the correct answer. That is the concept of pseudo force. So suppose net force is F dash and that comes out to be mg dash, so that would be equal to ma plus mg, right? So g dash equal to g plus a. So for a lift which is going upward, net gravity on this pendulum is not g, this is equal to g plus a. Similarly, for the lift going downward, net gravity would be g minus a. And how will you get that? You have to apply a force on this pendulum in the opposite direction in which lift is going. That is, in this case, lift is going downward, so you have to apply upward direction. So what would be the, once again, the net force? Mg dash equal to mg minus ma. So g dash equal to g minus a. And once, therefore time period would be 2 pi into under root L by g dash, and you can replace the value of g dash. Yes. Now suppose there is a simple pendulum in air, normal air, and there is no any condition or any restrictions like lift and all. So what would be the time period? Time period is 2 pi into under root L by g. Now if this same pendulum, it is put in water, what will happen? Will its time period increase or decrease? We know that time period equal to 2 pi into under root L by g. That means 2 pi is a constant that will remain as it is wherever you go. L is the length that would also remain same unless you approach the speed of light. So only thing is g. Will g change if this pendulum is put into water? So as soon as we put this pendulum into water, and you have to consider that water density is rho and the density of this bob is rho naught. So as soon as it is put in water, net upthrust would act on this bob, that is given by Fb. Now weight will act downward mg, and pseudo force you have to apply in the frame in the downward direction. So mg dash comes out to be mg minus fb, right? Mg dash would be equal to net force. This mg dash is nothing but net force. Here you can see that weight is acting downward, upward buoyant force is acting upward. So what is the net force? Just the difference of the two. So mg minus fb. So can you write m equal to density into volume? So density is rho naught into v into g dash effective gravity equal to rho naught into v into g minus rho into v into g. So from here we can cancel v. So therefore we can get g dash equal to 1 minus rho upon rho naught into g. G dash equal to 1 minus rho upon rho naught into g. And here we have considered rho naught by rho equal to eta. So you can replace that g dash equal to 1 minus 1 by eta into g. Right? Yes. You will understand it in a better way if you solve it on your own. Thank you.